Hello everybody, this is Holistic Learning Academy presenting the course on Java, Java EE, Spring and Hibernate. I am very excited to present this course to you. So let's jump right in and see what we are going to talk about. Now, why learn Java? That's the first question. And if you are watching this video, I believe you probably already have a good idea why you want to learn Java. I'm just going to cover some of the advantages you will have if you learn Java. First thing, Java is everywhere today. If you see desktop applications running in Java, all the cell phones, the mobile world has Java enabled, and of course web applications, there is no question Java is there in a lot of places, right? In fact, right now I'm using Google presentations, and I believe Java is here too, and it's heavily used in industry. If you see dice.com, there are 17,500 Java jobs, and I believe all we are looking for is one good job at a time, right? So I believe once you take this course, you should be able to take a Java interview and get a good job with a good company. And overall average salaries is higher for Java developers. That's a big advantage too. Granted, there are good developers in all programming languages, but all things being equal, Java developers get paid a bit more than other programming language developers. And Java is open source. What that means to us is we can download the software, learn it. All the resources are available to us for free, and we can implement things, and we can even develop products and sell them, all pretty much free of cost. And this is a big advantage. These days, a lot of big projects are developing frameworks to begin with in Java. For example, you can see Apache projects run by the Apache Software Foundation. A lot of projects. In fact, they have I think about 20-25 projects right now that they are supporting, and they have more added on a regular basis. All these big projects like Tomcat, which is an application server that we are going to study in this course. It's more of a web container. We'll study the difference in the course as we go along. That's one of the widely used projects. Solar is a search engine project, and it's a search engine library and also an enterprise server, Java server, which is again totally written in Java. Hadoop is used for distributed computing. It's a distributed, again, it also comes with what is known as HDFS, which is a distributed database running on a bunch of what are known as commodity servers, or just regular computers that are in a network. And this whole framework of Hadoop was developed with Java. And Mahout is a machine learning library, again developed in Java. And there are a lot more projects, not just these. Even if you just go out there, look for famous or commonly used projects, many of them are initially developed in Java, and then people develop it in other programming languages. Okay, and again, a lot of frameworks, Hibernate and Spring, we'll be studying in this course. And Android today, if you see, has pretty much taken over the mobile market. Vast majority of mobile market is Android market, and so if you learn Java, it's very easy for you to learn Android also. And there are next generation JVM languages. So what are those? These are a bit more advanced programming languages, what they are called as languages of the future, which makes a lot of things easy for you. Let's see what those are, like Scala, Groovy, and Clojure. These are programming languages which are based on JVM, which means they run on JVM. What is JVM? Again, we'll be seeing what JVM is. JVM is called as Java Virtual Machine, which is what takes Java code and runs it on the computer. And if you have a JVM available, you can also program in these other languages, which are pretty much similar to Java in the sense that they run on JVM, but other than that, they come with a lot of capabilities which will help you develop certain things much faster. Okay. So now let's see some of Java features. Java is a high-level language, as you know now. And if you're from a computer science background, you might have studied a machine language or an assembly language at some point. And Java is a simple and easy to read programming language, provided the programmer is good. All we mean by that is that even though the programming language is good, we still need to do our homework and learn it properly so that our code is good. To that end, I'll mention a point. There is a book called Clean Code by Robert C. Martin, which is one of my favorites. And we will be using a few pointers from that book. Later on, as we cover the course, we'll be seeing some of those points incorporated into the course, which basically helps you become a good programmer. And Java is an object-oriented programming language. If you did not know already, well, that fact is true at least until Java 7, but in Java 8, Java went out and also included the functional programming style. So it's not, you can't say it's completely object-oriented with Java 8. We'll see some of the new features, but still you can think of it as an object-oriented programming language, because Java was built ground up, which means from the beginning Java was never built as a procedural programming language and object-oriented programming as an afterthought. Java was built ground up as an object-oriented programming language. So what that means is initially we'll be writing everything inside. All your code is going to reside inside classes or objects. We'll see what the differences are in the next lecture, but here all you need to know is that it's an object-oriented programming language. And Java is architecture neutral, which means any operating system can run Java code. That's why it's called a write once, run anywhere language. What I mean by that is, let's say I have a Windows laptop and I develop Java software today. I could take that and run in any other operating system, provided I just follow certain simple rules. Java is a high performance programming language compared to interpreted languages like Python, because Java is a semi-compiled interpreted language, so it's somewhere in between C, C++ and Python, so it's much faster than just pure interpreted languages like Perl and Python. And it's also easier and shorter than C, C++, because we don't have pointers in Java, and garbage collection is automatic in Java. If you haven't used C or C++, just ignore this point, but if you have used C, C++, you understand what this means. And Java is highly evolving, like I said. Right now we are in Java SE 8, and if you just look at history of Java, somewhere in the late 90s is when Java 1.1 was released. And you may be seeing this again. Some people may say Java 1.8, some people may say Java 8. Just 1.x is same as Java version X. That's just some versioning, naming inconsistency, I should say. But whenever somebody says Java 1.5, it's the same as Java 5. Okay, and today we have Java Standard Edition version SDK, or the Java JDK version is 8. Okay, and Java is also a multi-threaded programming language. This is also one of the fundamental building blocks of Java, which means that you could take advantage of multiple cores or multiple processors that you may have available. If your program runs in a single thread, all it can use is only one processor, but Java was built ground up as a multi-threaded programming language, which means it can take advantage of multiple cores. We'll be studying concurrency in this course. Okay, so at that time we'll see what this means. Okay, so here are a few disadvantages. Uh, let's see. Statically typed. What this means is every variable in Java has to have a type associated with it, and you can't change its type once it is declared. Even though it looks like a disadvantage, it can help you prevent a lot of bugs, but it can slow down your development a little bit. So it's again not a pure disadvantage. I would say it's still a feature, but it's a disadvantage in the sense it may slow up development time in certain cases. In Java, like I said before, may be slower than C++, because in C++, once you compile your code, you get machine code to run, which can directly run on the machine. But in Java, once you use the Java compiler to compile your code, you still need a Java virtual machine to take your compiled code, or what is known as a bytecode, and run it on the machine. So we'll be seeing this in the first lecture. So in that sense, Java may be a bit slower than C++, and Java is also a bit more verbose than interpreted languages like Perl and Python, because Perl and Python are very quick for development. Same in Ruby. Those languages have advanced operators, advanced functions that can do a lot of things. In Java, it may be a bit slow. And then slower development time than agile frameworks like Rails, right? So that's a bit of a problem again with even with Spring framework. As you see, Java development is made easier with Spring, but still when initially Spring came out, a lot of things had to be configured manually. But if you see an agile framework like Rails, it comes with built-in features. So you just follow the rules of the framework, and once you follow the rules, certain naming conventions and stuff like that, you can just have a working application ready very quickly, because it's what is called as a convention over configuration approach. Now, just as this point mentions, Grails, which is built with the Groovy programming language, solves this issue partially at least, but we need to learn a lot. But then if you can go online and look at Ruby on Rails, it's so easy to develop. So in that sense, Java is a bit slower as far as development time goes. Anyway, so let's jump into the topics that we are going to study. First, we'll be studying Java language and fundamentals. Even though you may know this already, I would still encourage you to go through the lectures here and attend the classes on this, because you might have missed a few points maybe, or some of the interview questions and other things will be covered. So I would encourage you to go through these lectures anyway, even in case you know this already. It may just be a good refresher for you. So we'll first be studying primitives. What those are? These are the simple types available for us that Java itself provides. Then we'll be studying control statements. If you come from another programming language, most of them you already would know, like if condition, branching, loops, and all this. We'll be covering this in some detail. Then we'll study classes and objects and object-oriented programming. Then polymorphism and inheritance, and what those concepts mean and what they help us do. And then we'll study what are known as abstract classes in Java and interfaces. These are very powerful programming concepts, and any basic Java interview will be asking some questions to you about these topics. So we'll be covering those in detail. Then we'll move on to advanced concepts like exceptions, collections. Collections is a very powerful framework in Java that helps you do a lot of things, and we'll be studying that in some detail in this course. And then we'll study concurrency or multi-threaded programming, and then generics. Generics is more is very helpful for you to write code that makes your code essentially type independent. So we'll study what that is. And then Java 8 features, some of the new features that came in. And again, I may not cover Java 8 features after generics, because you don't really need all the features for the rest of the course, depending on where it fits in. I may either cover it after generics or I may cover it at the end of the course, okay, as one of the last lectures. Then let's see, we move on to web development, and in web development we'll be using the Tomcat web container for all our projects. It's a very lightweight container that only supports the web component of Java enterprise development. And after Tomcat we'll study servlets, JSP, JSTL, custom tag development. All these are again very closely, JSP, JSTL, all these are tied a bit more to HTML. So if you have a good background in HTML, you can understand, but even otherwise you can just pick up HTML very easily as you go through the course and see what more can JSP provide on top of HTML. Basically JSP introduces Java into HTML. That's what it is. So let's study here listeners, what those are and why we need them, filters, and then layered architecture. What that means we'll see. That just helps you develop your entire web application component by component. After web development we'll be studying databases and JDBC. We are going to use MySQL, which is a very commonly used open source database, and then we'll be studying JDBC, which is what helps Java connect and talk to MySQL and run queries on MySQL database. And then we'll also be covering how to set up a connection pool, which is very important because in production application that's what you would be using. Then we'll study build and logging frameworks, of which Ant is the one that's been there for a very long time. And after Ant we'll be covering Maven. Maven is again what is used very commonly these days, and there is also one more build framework called as Gradle that we won't be covering in this course, but once you know Maven, I think you are pretty much okay. And then we'll study logging framework with SLF4j and Log4j. We'll also be covering testing, and in testing most commonly used framework today is JUnit. JUnit params just gives an extra capability on top of JUnit. And we'll also study mock testing with Mockito. I don't see a lot of basic Java course covering Mockito, but I believe it's very important, which is why I added this topic to the course. Then we will move on to Spring Framework, which just is going to make your life very easy with Java development. A lot of boilerplate is removed with Spring. A lot of things are made easier with Spring, especially the enterprise application development like web applications. So we'll study what those are. A basic concept of Spring is dependency injection. It's a scary sounding term, but trust me, it's a very simple concept, and once you get a grip of it, you will pretty much know what it is. And then we'll study aspect oriented programming and what are aspects. Then Spring JDBC template, it just makes JDBC access very easy with Spring. Spring MVC is a model view controller, which is framework or a design pattern used for web application development. So we'll study what is a model, what is controller, how to set up views and all this. And then we'll be studying Spring Forms. You might have filled out forms, HTML forms, or maybe even Spring Forms on the web. So we'll be studying how to build those. Then we'll study REST. And REST services are very easy with Spring. But even though sometimes we know the definition of the term REST, you can look up online. Until you develop an application, we really don't know what REST is. So we'll study REST and what is a REST API or a REST web service. Then we'll study object relational mapping, and these days ORM basically is just Hibernate in Java world, at least in 80-90% of the cases. So we'll study Hibernate, and then we'll move on to continuous integration with Jenkins. We'll also be covering by the end of the course how to prepare for your interviews and how to do your job search. We'll be covering again overview of algorithms and data structures, design patterns. These are just as more for a refresher for you before you can start taking interviews confidently. Because after studying all those frameworks, company requires very strong algorithms background, we need to be prepared for those too. I will tell how to prepare your resume, how to interview, and then some of the negotiations, and how to work with recruiters, and how to succeed at your new job. Right, so all these, I believe, some of these are soft skills based on my own experience and things that I have gained over past few years, and online resources. I've just put together a few pointers that may help you here. And how did I design this course? This course is designed with simple and practical working examples. That's been one of my own thing that I was looking for whenever I wanted to learn anything new. I could not connect the dots initially between Java and Spring Framework and how it works with the database and all that. So this course is designed with very simple and practical working examples, and it helps you set up projects very quickly. Otherwise, we'd be spending a lot of time on the internet because some configuration is not right, or we did not know where to keep a certain certain code or a framework file or anything like that, any configuration. So we'll be covering how to exactly set up your projects. And then this covers materials equivalent to about 12 books, probably more. I might have just picked up a few things from few books that I may be including here and there. But again, that's something that may take you a long time to study 12 books. So this course hopefully will just give you the essence of all those books, just exactly what you need to succeed in your course. 13 plus years of software development experience from myself, and all the years of experience that I've gained from the books too, from all those developers, and a lot of online resources. All that has gone into preparing this course. I have myself used Stack Overflow a lot whenever I was preparing the course. If I did not understand a concept or some question was there, I would ask on Stack Overflow, and people there have helped me. So all this experience is there inside this course, and it covers topics and ideas in a logical sequence, so you can remember all the ideas very clearly. And like I told, we also help you with resume preparation. Course covers this, and then we'll be conducting mock interviews for those of you who need some practice, and then give you connections to recruiters, so your resumes can be forwarded to the correct companies that you want to work for. And our sincere hope is that you can take practically any Java interview confidently after you go through this course. Anything Java, Spring, Hibernate, any interview that requires those technologies as the main technologies for the job, you can take those interviews very confidently. So with that, I'm concluding this first introduction lecture, and I look forward to talking to you in the next lectures. See you later.